Okay, good morning. Welcome to our last notes for Unit P, complex numbers and quadratic equations. So we talked about earlier that up until this point in time in this class, if you had a negative underneath a radical, we just said it was either non-real solution, or if it was a cubic, you'd be able to simplify it. Now we're saying, okay, we're going to talk about this imaginary number I, which is defined as I equals the square root of -1. So, I know that we have talked about this before, and some of you guys already were pretty knowledgeable, but we just want a quick refresher on how you use the imaginary numbers or complex numbers. So, I know it's kind of weird to call it imaginary, but really, it's really a complex number of the form a plus bi. And if it just has the imaginary part, then that would be just the bi, I guess. So, first things first, how to simplify negative square roots. So, what I like to do is right away when I notice that I have a negative underneath the radical, I just I just take it out. I don't even want to deal with it. So, I'm going to separate the problem to the square root of 25 times the square root of -1. And now, based on this definition, I know that the square root of -1 is just I, and the square root of 25 is 5, so this becomes 5i. Now notice I make my eyes a little different. I'm sure Ms. Tucker and Mr. Conciali will each kind of do their own eyes. So, I like to do it, either like this, like the old English version, a little cursive, or, if you like, if you want, you could do it like this, okay, or, even more creative, I guess. Okay, but I don't make my eyes go up and down because otherwise they look like a one, and especially since I'm writing on the notability, it's not the neatest. So, I'll make my eyes look a little funny, just kind of on purpose. So look at example 2 here. Again, I notice that negative, and I just take it out. I don't even want to deal with it. So it's a square root of -1, but we know that the square root of -1 is just I. So no matter how we simplify this, we know there's going to be an I in there. So this is going to be 3 times 4 times b squared times I. And you can just write it out like that, 12b squared I. Now, if there is still a radical involved, like for example here, when we simplify this, 2 times the square root of 12 times the square root of -1, I much prefer, and I think all the other teachers will agree, to move this I next to the right with the coefficient, so not behind the radical. And here's why. So we simplify this, and we have 2 times 2 root 3i, 4 root 3i. Now, if you leave it your answer like this, it kind of looks like the radical and the I are together, especially if you're like just a tad sloppy and your line goes too far. And now, as a teacher, I'm looking at this thinking, well, how do I know that they know that the I is already simplified and does not belong underneath the radical? So it's much, much, much better to just go ahead and rewrite it along with the coefficient. So it's 4I root 3. This is the kind of the preferred method, just so there's no confusion. All right, so now this part is review, and you could go as fast as you want on this, as slow as you want. I would kind of prefer if you guys try these on your own, so pause the video and try it. But when we get down to it, there's a couple of these that are going to be a little tricky. So, for example, E, F, and G. I'll go back to the top here in a second. Okay, so the reason why these are tricky is because, last year you guys got your cut a little short, and I'm not sure how far you guys got with imaginary numbers. So let's see if you remember. We know that I to the first, that's just I. I to the second, that's -1. I to the third is -I. I to the fourth is +1. And then this pattern continues. I to the fifth, well, you can memorize that, which I don't recommend, or you can understand that it's really I to the fourth times I to the first, and I to the fourth is just going to be 1, so this is I to the first, or I. I to the sixth, that's I to the fourth times I to the second. I to the fourth is just 1, so now it's I to the second, which is -1. I to the seventh is I to the fourth times I to the third. I to the third is negative I to the fourth is 1, so that's just negative I. And an I to the eighth, well, that's I to the fourth times I to the fourth. But really, any exponent that's a multiple of 4 is going to be 1, so that's 1 times 1, which is just 1. And so now the pattern, and some of you guys discovered it on your own, and some of you guys need a little bit more help, is when you're looking at the exponent on I, you want to see what is the biggest multiple of 4 that divides into it evenly. I even had some students that were like, well, I divide by 4, and then my remainder is what is either going to be 1, 2, or 3. So here, I to the 36, well, 36 is divisible by 4 evenly. It's a factor. It's a multiple of 4. It's 9. So that means that 36 is a multiple of 4, which means the answer is automatically just 1. However, I to the 43rd, well, 43 divided by 4, well, that's 10 with a remainder of 3. So that means that it's really the same thing as I to the third, and I to the third is negative I. Some other techniques that I've seen students do in the past is they just say, well, this is just I to the 40th times I to the third. I to the 40th, since that's a multiple, 40 is a multiple of 4, that just becomes 1, and I to the third is negative I. So it's 1 times negative I, which is negative I. Okay, so different techniques, whatever you feel more comfortable with. And now for G, we're just using exponent rules here. So 6 times negative 2, those are just coefficients, just numbers. So you just multiply those together. And then I to the second times I to the 12th, well, that's I to the 33rd over 4 I to the 10th. And again, continuing with just exponent rules here, negative 12 divided by 4, that's negative 3. And I to the 33rd divided by I to the 10th is I to the 23rd. And then, number of ways I just showed you here. You can either divide it by 4 and look at the remainder, or you could just say, well, that's just I to the 20th times I to the third. I to the 20th, that's just 1. I to the third is negative I. So now this is negative 3 times negative I, which is 3I, positive 3I. So again, there's always more than one way to do a problem, but this is the way I like to show, simplifying with the exponents first. But some students may want to just go ahead and simplify here, simplify here, simplify here. You could do that. I just think it's going to be a little bit more work, okay? So these were the 3 kind of toughies. The rest of these, hopefully, if you've done them already, pause. We're going to get 11I. Here, this is 4 times 81 is a perfect square, so that's 4 times 9 times a to the second times I. So that's 36a squared I. Okay, 72. Again, I just like to get rid of that negative number first. I don't even want to deal with it. And now I break down 72, which is the square root of 36 times the square root of 2. So that is 2 times 6 times root 2 times I. But I'm going to move that I so that it's not, there's not going to be any suspicion that we don't know what we're doing. And so this becomes 12I root 2. Over here, same idea. I'm going to just get rid of that I. I just don't want to deal with it. So I'm going to take out the negative 1 here, break down everything else. So negative 9 times, okay, the square root of 24. Well, that's 4 times 6. So 9 times 2 times x times y squared, because there's a 4 there. And then run out of room. Try this little tool. Move this over. Okay. Better. Okay. So now negative 2 times x times y squared times I root, remaining is the 6 and a y. So now let me simplify this completely. Negative 18 x y squared I root 6y. Okay, so moving on to this one. The common mistake that a lot of students make with this is they see the 125 and the 1/3, and they want to divide it by 1/3. But in reality, this is an exponent. So it's 125 to the 1/3 power times I to the 5th power, because it's 15 times 1/3. If you want to look at it this way, it's 125 to the first power, so it's 1 times 1/3. Now 125 to the 1/3 power is the same thing as taking the cubed root of 125, so this is just 5. And I to the 5th power, well, we have our little chart here, but even so, that's I to the 4th times I, so this is just 5I. All right, so now again, I'd like you guys to try these. So just pause it, but I'm going to kind of continue. So when I look at these, I like to kind of break them up and look at the individual problem instead of looking at the entire problem as a whole. I think it's a little intimidating to look at the whole thing. So when I break it up, and if I just focus on this, well, the square root of negative 144, that's 12i. 12i times 2, so it's 2 times 12i, which is 24i. I to the 25th, well, you can either divide it and get a remainder of 1, or look at it as, well, that's I to the 24th times I to the 1st, so it's just I to the 1st. So this is plus 3I. And negative I to the 3rd, well, I to the 3rd is negative I by definition here, so this is just plus I. And now 24 plus 3I plus 1I is 28I. Okay, over here again, looking at individually, all right, let's use our exponent rules here. So it's 5I to the 20th times I to the 15th. So that's 5I to the 35th over I to the 7th. And then I to the 35th divided by I to the 7th, well, that's 35 minus 7, so that's 5I to the 28th. And 28 is a multiple of 4, so this is just 5 times 1, which is just 5. Okay, over here it's negative 3 times the square root of 4, negative 4, so that's negative 3 times 2i, and negative 3 times 2i is minus 6i. And over here, I have to distribute a 4i to each term, so this is 12i minus 8i squared, and we can never, you're not finished until you just have a I to the first power, so keep that in mind. So even as we get down here, and this just stays as plus 12i, I to squared is really, by definition, negative 1, so this is actually 12i minus 8 times negative 1, so this is 12i plus 8. And now we combine our like terms here, so 5 and 8 and negative 6 and 12i to get 13 plus 6i. So not too bad if you split it up into its separate parts here. All right, so now the complex conjugate. This is something that students tend to struggle with because they forget to use it. So let's read this together. For complex numbers, 1 minus 2i and 1 plus 2i are called complex conjugates and are always in the form a plus bi and a minus bi. The conjugates will always simplify to a real number. So just to kind of like play around with this and get used to using this, you know, if I have 2 plus 3i, the complex conjugate would be 2 minus 3i. If I had 1 minus 4i, the complex conjugate would be 1 plus 4i. If I had negative 3i, the complex conjugate would just be 3i. So the first thing is recognizing that you need to use a complex conjugate. And the reason why is the same reason as if I have 1 over the square root of 3 in the denominator. You cannot have irrational numbers in the denominator. That's just a rule. I didn't make it up, okay, but I follow it. So this is the square root of 3 over the square root of 3, which is root 3 over 3, right? And we're all familiar with this. Well, we have to do the same thing here, because remember, I is the square root of negative 1. So that's an irrational number in the denominator, and the way we fix it is by using complex conjugates. If you just use 2i, then you'd still end up with an i in the denominator, so you have to use the complex conjugate, which is 3 plus 2i. Now, at this point, if we were in person, I would show you guys how to just enter it in your calculator. There is an I button, okay, and it is on your calculators. It is underneath the, look at my calculator right now. It's right where the decimal point is. So it's where the decimal point is, and if you just press second decimal point, you get the I button. Since we're not in person, and since you can't see my calculator, I'll tell you to do it by hand, but if you do it with your calculator, make sure you use parentheses. So doing it by hand, this is 15 plus 10i over, now I distribute, 9 plus 6i minus 6i minus 4i squared. And right away, we see why we use a complex conjugate. Your I terms are going to eliminate each other, and you're left with an I squared, which we know is -1. So this is 15 plus 10I over 9 plus 4, which is 15 plus 10I over 13. Now, on a quiz or a test, that answer is 100% correct. There's not simplifying involved. However, for Math Excel, they want you to write it as a plus bi form. So that means you have to write it as 15 over 13 plus 10i over 13. All right, so that's something to think about. If you try it on your own, you're like, well, why do I keep getting around on Math Excel? This is why. You have to do that part. Okay. All right, so let's try it here. This one is a little bit more involved, but really not that much different. The first thing is, remember, recognize you need a complex conjugate. So this becomes 2 plus 3i. 2 plus 3i. And now, if we're in person, or if you could figure it out, you could put the entire numerator in your calculator and the entire denominator in your calculator. But we're not in person, so you're going to do it by hand, or I'm going to show you how to do it by hand. So that's 14 plus 21i plus 8i plus 12i squared over 4 plus 6i minus 6i minus 9i squared. Now you can have a complex number in the numerator, so don't think oh, but how am I going to get rid of that I? You don't need to. It's in the numerator. The only problem is in the denominator. So now remember, this I squared is really -1. So now what I really have is 14 plus 21i plus 8i minus 12 over 4 plus 9. And now, simplifying my numerator, I get 2 plus 29i over 13. And this answer is great for us, but remember, for Math Excel, they're not going to accept that. So for Math Excel, you have to write your answer as 2 over 13 plus 29i over 13. Okay, so now, here's the main reason for solving these understanding complex numbers is we have to use them when we're solving. Okay, so this part will take a little bit longer, but we are giving you 2 days on this. All right, so solve each equation in a complex number system. X squared plus 4 equals 0. Well, we can't. There's not such thing as a sum of squares. So don't think about that's x plus 4 and x plus 2 and x minus 2. No. We have to solve this using the square root method. So x squared equals -4, and then we take the square root of both sides. And in the past, I would say, well, write no solution, but now we know complex numbers, so now we can officially say it's plus or minus 2i. Over here, we could try factoring, but there are not two numbers whose product is 13 and whose sum is -6, so you have no choice but to use a quadratic formula. So x equals the opposite of -6 plus or minus the square root of -6 squared minus 4 times a times c all over 2a. So x is equal to +6 plus or minus. Remember, when we're doing this, all I want you guys to do is put this part in your calculator. Don't put the entire thing in your calculator. So this is -16 all over 2. And this problem looks familiar. It's because we did it before, but in the past we said, oh, look, you have a negative underneath the radical. That means no solution. But now we're saying, we got this. So 6 plus or minus 4i over 2. So that is 3 plus or minus 2i. And you can actually answer like that in Math Excel. Okay, so similarly on this problem here, again, you could try factoring it out, but it's not going to work. So now you have to use a quadratic formula. So x is equal to the opposite of 6 plus or minus the square root of 6 squared minus 4 times a times c all over 2a. So x is equal to -6 plus or minus the square root of, remember, just put this in your calculator, okay, and that is -4 all over 20. X is equal to -6 plus or minus 2i over 20. And, whoa, no, what's this? Okay. All right, so now some people, hopefully no one does this in this class, will like try to cancel out the 2 here, and it doesn't work that way. You have to factor a 2 from each of these terms. So x is equal to, if I take out a 2, this is -3 plus or minus I over 10, the 2 times 10, and if I cancel the 2's out, then my final correct answer is -3 plus or minus I over 10. In Math Excel, this is great for us, but in Math Excel, it's going to be a little bit more work, and you're not going to like it, but they're going to want you to write -3 over 10 plus or minus I over 10. Okay, because you got to write it in the complex number form. All right, I like problems like D and E. They're kind of cool problems because these are called quadratic-like. So they behave like quadratics, but they're not quadratics because of the exponent is to the 4th power. So you could call them like quartics. But normally we can't solve a quartic equation without other techniques, but we have other techniques, and those other techniques are using, since they're quadratic-like, we're going to treat them like a quadratic. So two numbers whose product is 36 and whose sum is 13. Well, we got that. That's 4 and 9. So this is x to the 4th. Well, I'm going to do it the other way. So product is 4 plus 9 and 4 times 9. So we're going to write this as x squared plus 4 times x squared plus 9 equals 0. All right, so now the big thing here is, notice the 4th power, and now when I factor it, it's x squared. And you could check your answer by multiplying it out. But now here's kind of the neat thing about this. So it's x squared plus 4 equals 0, and x squared plus 9 equals 0. And this is why it's quadratic-like, because we're going to solve it like a quadratic, and now we're going to use the zero product property. And now if we continue solving this, when we continue to get x by itself, we're starting to see things unravel here. And now I take the square root of both sides. All right, and x is equal to plus or minus 2i. X is equal to plus or minus 3i. And sometimes students on Math Excel, they kind of get upset about this part as well, is they forget the commas. So if you're going to do this, if you're going to list it in Math Excel, you're going to have to say 2i, comma, negative 2i, comma, 3i, comma, negative 3i. So in Math Excel, not only does it challenge you in math, but it also challenges you in following step-by-step directions. So it's a pretty good tool because that's an important life skill, is following directions. Okay, same thing over here. Try it on your own. Press pause, but I'm going to continue. And so this is x to the 4th plus 3x squared minus 4, which is two numbers whose product is 3 and whose sum is -4, and that is 4 and -1. So when I factor this, this becomes x squared plus 4 times x squared minus 1 equals 0. And this problem is a little bit different because, this is still the same. X squared plus 4 equals 0 and x squared minus 1 equals 0. However, when you solve it, you're going to get two complex numbers and two real numbers. So x squared is equal to -4. X squared is equal to negative or positive 1, or just 1. And then we take the square root of both sides. Square root of both sides. Don't forget your plus or minus. And we get x is equal to plus or minus 2i, and x is equal to plus or minus 1. And so I'm listing out my solutions for Math Excel. This becomes 2i, negative 2i, 1, and -1. Now we're going to learn this later on in next semester about 4 answers is raised to the 4th power, raised to the 4th power. So that's something to think about. Even here, 2nd power, we have 2 non-real answers. 2nd power, 2 non-real answers. Now you'll say like, well, sometimes you get one solution. Yeah, but we're going to learn that's repeated. But that's not neither here nor now. So that's the end of our notes for today. Thank you.